right, everybody. Welcome back to EverBlock Tech, your go-to place for all things Web3. I am your host, Gitatron, and thank you for coming to this channel again. If you like the material here, be sure to like and subscribe and share it with whomever you think might benefit from it. So a little bit about me. I got involved into blockchain technology and wanted to be a developer because I was tired of getting scammed, to be honest with you. I was just sick and tired of running into projects and aping in only for them to rug pull and run away with all the money. So I figured if I learned how to code, I would be able to read into the code to be able to at least take a more educated look at what I was getting involved in, as well as take more of a proactive stance towards actually just creating the products, creating the currencies, creating the apps to have more control over the situation for myself and to create an atmosphere of safety and security for other people like me who just want to build wealth and enjoy the new technology. So that's why I got involved. And that's what brings us here to this video today for this coin LOL. I opened up my wallet one day and I saw that I was up like $80,000. I'm like, I'm rich, and I was looking around trying to see which token it is. And it turns out it was this LOL token. And I couldn't really remember, did I buy this token or not? And it turns out that I didn't. But what I did was I immediately started investigating. Now, here's a little pro tip for you if you're new to blockchain technology, if you're new to these currencies. What you don't want to do if you suddenly receive a random token in your wallet is interact with it in any way. I mean, don't try to swap it, don't try to send it, don't interact with it at all, because the thing about it is you don't know what that token is. And there are people who have figured out how to design code in a way to where as soon as you interact with the token, it drains your whole wallet. This is prevalent on Twitter, especially when you see fake Twitter accounts that look like the real deal. It might say it's the Avalanche Foundation, or it might say it's Chainlink, and you'll see a button on there that says claim your airdrop or claim your tokens. And you click the button thinking you're claiming some tokens, but really what you're doing is you're signing away the life of your entire wallet. How does that work? I'll show you how that works real fast before we get into this LOL token. Um, so here we have a website that I'm developing for Walter the Wise. All right. And as you can see here, it says localhost 3000. That's because this is running on my computer in port 3000, which is a development port for building websites and software. So you can see here, developed by Gitatron. This is actually something that I'm working on. So you see these buttons here: connect Para Wallet, staking status, available rewards. Now, this is what you see from the user interface from your perspective or our perspective as users of any website, really, even the last website we were looking at. This is the user's perspective here, right? But when we want to look at the developmental perspective, the back end of it, the code that's involved, it looks something like this. All right. This is exactly what you just saw, just in code form. All right. As you can see here, Walter the Wise staking dApp under construction, just like it said in the one you see here. All right. Now let's make this so that we can see them both at the same time. Okay. All right. So the thing about it is these buttons come with functions. They come with commands, okay? So when you look at this button here, connect wallet, right? It'll say connect Para Wallet. So let's look for that. Here it is right here. So it'll say on click connect Para Wallet. And when you scroll over just a little bit, you'll see the words connect Para Wallet here. So when you click this button, it runs this command here, which is the connect Para Wallet command, which is a constant that I set up here. So when you click this, this happens. All right. Click this happens. All right. As you can see, it has some variables set where we have the Para Wallet is the new Para Wallet connection and is awaiting to connect and setting the wallet address and all that. All right. Now the thing about it is, without knowing how this stuff is built, you'll think you're just going to be connecting Para Wallet, right? But I could put any command behind there. As a matter of fact, if you really knew what the button was going to do, it might say something like this. All right. We'll just change this to scam, right? We'll change the button title to scam. All right. So in a minute, you'll see how it changes from connect Para Wallet to scam over here. Let's go ahead and refresh. We really don't have to refresh with React. This app was built using React. It's a hot loader, so it'll load just instantly when you save it in the development environment. However, my computer's running a little slow right now. I got a lot of things going on in the background, so I'm just going to go ahead and refresh just for that purpose. And I'll leave that on screen so that you can see it. And I'm going to go ahead while that's on there and just change that back without saving. And you see this little white dot here. That means you made some changes that have not been saved. And we'll just wait on that for just a second here. Matter of fact, while we're waiting on that, let's get into what we were working on before. All right, I just wanted to stay on the screen so that you can see I'm not doing anything tricky in the background. Okay, so we'll make this, uh, you see my mouse still moving here. I don't have two mice or anything like that. All right, we'll just make smaller so that you can see I'm not fooling around with that either. All right, and while that's loading, we'll talk about this token here. Well, there it is right there. All right. So as you can see now, this button says scan, right? I'm going to turn it back to Connect Pair Wallet, which all I have to do is save because I hit Control Z for undo. And in a minute, this will say Connect Pair Wallet again. Anyway, I'm going to take all the time showing you that. Just wanted to let you know that those buttons do whatever the developer of the website told it to do and not necessarily what it says it's going to do from your perspective. So if you ever get a random token in your wallet, don't interact with it. Don't send it. Don't swap it. Don't do anything with it because it's probably a scam token meant to drain your wallet. So let's look. This is just going to be an overview of the smart contract involved with this. Now, how I figured out this was a scam has nothing to do with the smart contract, actually. At the time, there was a chart here and there was a markets tab up here. And I went to check on the liquidity and found out there was no liquidity. So let's look at something that does have some liquidity like Tron. All right. Look at Tron token for just a second. So I'll show you exactly how I found out that I was going to be scammed was because when I went to the website, there was no liquidity. So let's just let this load. All right, markets. As you can see, there's markets here now. And all this was populated at the time. All right. And here we go. So you can see there's Tron and Bitcoin. All right. There's Tron and USDT, okay? And you can see that there's a lot of liquidity there, all right? High scores, okay? So you can see here that there's money passing through. But with the LOL token, there was none. So I didn't mess with it, and eventually it just disappeared out of my wallet the same way it got there, all right? So let's go back. You might want to know how to find the smart contract associated with these cryptocurrencies. All right. They all have to be deployed on chain. So here's the contract address here. So we'll click that, which we really don't have to because it'll take us there on base scan, I believe, when we click this. But let's see. We'll click on it. All right. This is going to be the Explorer for it. It was deployed to the base blockchain. And yeah, here it is. So we didn't even really need to copy that. So tells you everything. Max total supply, 96,000 holders, all these transfers because it sent it to all these people. All right. So when you scroll down to contract here, okay, you can actually view the contract. Now there's 14 contracts involved with it. All right. We're just going to go over token.sol today. There's a lot of other contracts that are being called by this contract, but for today, we're just going to worry about token.sol. So let's go back up here. All right. Enlarge this so we can see it. All right. So let's dive into it. All right. So this is going to be a detailed explanation of the Solidity smart contract for anyone completely new to coding. All right. So we'll go line by line, explain the concepts and functionalities incorporated in the contract. So here, where it says just forward slash asterisk LOL for asterisk forward slash. This is just commenting it out. So this does not get compiled with the code. So the computer kind of ignores this. This is just for humans to give comments. It's a comment to let you know what's going on here. This right here is the license identifier, as it says right there, the pragma statement. All right, it's letting the computer know which version of Solidity to compile this contract under, right? 0.8.25. So if it tried to compile under a different version, it might work, but it might not work as well because there could be some dependencies that changed. within the new or different version, and when it goes to compile, there's errors because it was made for this version. Okay. Um, so you have your imports here. Okay. So these imports, they bring in code from other files, all right, enabling reusability and modularity. So this is what each one likely provides, all right? So ERC20 and ERC20 from ERC20.sol. If you remember, ERC20.sol is right down here, right? So when it imports ERC20.sol and ERC20.sol, it's importing this code into this code so that you don't have to, it just keeps the code condensed so that you don't have to have all that code in one file, right? All right. And it's doing the same thing for ERC20 burnable. All right. Ownable two-step. Now I know ownable is also available in Open Zeppelin, and this is what looks suspicious to me. Like they could just imported from the libraries, but they're doing it individually here, which makes me think that maybe they changed a couple of things in there to customize it a little bit more, right? And then you have the Uniswap V2 factories imports here as well, all right? So these are part of the ERC20 standard for Ethereum tokens, defining the mandatory methods and events. So if you were to go on to ethereum.org, you could go into the documentation and see that there's a framework that these contracts have to be built basically to model, right? It has to have certain things involved that will make it compatible with the Ethereum blockchain. All right. So you see ERC20 burnable. All right. This adds functionality to destroy or burn tokens, which will reduce the total supply, which people sometimes do in order to increase the price. Because supply and demand, the less supply there is demand, which is why the price of Bitcoin keeps going up, because the more Bitcoin that gets mined, the more transactions get processed, the more is created, and then there's less total supply to go around, right? Okay. So ownable and ownable two-step. That's going to add ownership management to the contract, allowing certain actions to be restricted to just the owner. Who's the owner? The owner is the person who, or the wallet, who deployed the contract itself onto the blockchain, all right? Or whoever they set the owner as. It could be a different address, actually. They could set it as a different address, but it just adds ownership management to the contract, all right? Allowing certain actions to be restricted to the owner. And the ownable two-step likely introduces additional security by requiring a two-step process to transfer the ownership, all right? Now, there's import for initializable is used for contracts that will be deployed as part of an upgradable system, ensuring that initialization only happens once, right? And then the Uniswap V2 factories and all of that is, those are interfaces to interact with Uniswap. If you're familiar with Uniswap, even if you're not, Uniswap is a decentralized exchange of DEX where people swap tokens. All right. It facilitates actions like liquidity pairing and sometimes flash loans with some of them. All right. Now we're getting to the meat and potatoes. All right. The contract declaration. All right. So they gave it a name, as you can see, LOL. Right. And then they say it is ERC20, is ERC20 burnable, is ownable two-step, is initializable, right? So that's when they are inheriting these contracts into this. So everything that these do, they can call the functions from these contracts in this contract without having to write out that whole contract again, right? So this keyword is used to define a new contract. So LOL is the name of this contract, right? And these are the other contracts that it inherits, and it allows them to use the properties and methods of those contracts, all right, as if they were written inside, all right, similar to how a child inherits traits from their parents, right? So then we get into the state variables, all right. So we have uint 16, excuse me, which unsigned integer 16 public. This means that this contract can be called, some of these functions can be called from outside of the contract, right? Swap threshold ratio, all right. Uint 256 private, that means it's private. It can't be seen outside of the contract. It's private, all right. And this is the variable assigned to that. Then you have the address, public, LOL address. You see it, all right. These parts are the state variables, but that we are state variables, and they are data that's stored on the blockchain that persist between transactions. All right. So an unsigned integer, uint, as we have UINT 16, UINT 256. That's going to be storing the ratio at which swaps should be executed here with the swap threshold ratio, right? The LOL pending here, it's going to be a private variable holding the amount of LOL tokens pending the swap. So then you have the LOL address. That's going to be the wallet address related to the LOL operations. All right. And bet you probably already figured out what LOL fees is going to be about. All right. That's going to be an array, which when you have this 3 here, it's an array of counting zeros. So there's going to be 4 integers here, 0, 1, 2, 3. All right. Um, Holding 3 different fees, perhaps related to buying, selling, and transferring. All right. And then is excluded from fees is going to be a mapping. All right. So you see here mapping, and it's going to address, is going to be talking about an address that's either bool, right? True or false. That's what bools mean. It's a value that's either true or false. It's a Boolean value. All right. And it links these addresses to the Boolean value. And it's used to keep track of whether an address should pay fees or not. And think of mapping like a dictionary or a phone book linking names, which would be the keys, to phone numbers, which would be the values, right? All right. So then you come down to the total fees. All right. Same concept there. And then bool private swapping, right? Which is a Boolean to indicate if a swap operation is ongoing, preventing re-entry into certain functions. Because one of the attacks that attackers like to do is a re-entry attack where they call a function multiple times before it completes the first time, right? So this is probably here to indicate if a swap is ongoing, true or false, to prevent re-entry into other functions, all right? All right, and then we also have our trading enabled, which is, guess what? It's going to enable trading, all right, to figure out if that's true or false, that's happening or not, and if it's excluded from trading restriction. You know, some jurisdictions don't allow crypto trading or any type of interaction with blockchains, so they put that in here. And then here are the errors: cannot deposit native coins, the address that it's on, and the account involved, invalid swap threshold ratio, UINT 16, and then the actual swap threshold ratio. So these are going to be all the errors, all right? Errors that could come up, all right? And then these events are emitted on chain, not on train, on chain whenever something happens, right? These are the updates that happen on chain whenever something happens. Now, these don't have to be there, but we put them there. They're put there for transparency so that things can be seen when it's done on chain, all right? Now we're into the heart of this thing, which is the constructor. All right. The constructor, ERC20, Unicode, LOL, Unicode, LOL, ownable, message.sender. So this is telling me that the person that is, or not the person, but the wallet that is deploying this contract is the owner, because message.sender is going to, and ownable is going to be the wallet that is actually deploying. All right. So this is the address that's going to receive the total supply. So the 100 million tokens looks like went to this address initially. All right. Um, Update swap threshold. It's got updated to 50. All right. Do we see that up here somewhere? Let's see. Swap threshold. All right. So they just made it 50 right here in the construction. This is the constructor is kind of like what establishes the state of the smart contract when it first is deployed on the blockchain. Okay. So the LOL address setup. All right. This is saying where it's going to be set at. So the constructor is a special function that is executed once when the contract is first deployed, used to initialize the contract's data. So in this case, it sets up the token with a name, a symbol, defines the initial owner, which would be that message.sender, and then it sets the swap threshold and initializes other settings related to fees and token distribution, which you can see here. All right. All right. Then it has the mint and transfer ownership functions here. All right. However many tokens it is, 10 times decimals. All right. Transfer ownership over to this address here. So ownership goes from here to here. All right. This comment says token is not upgradable function after constructor finishes post-deployment setup. This may or may not be true. Again, this is a comment, right? It has nothing to do with what's hard coded here. We have to look at the code because again, this token did some really squirrely things when it first came out. So let's look at the functions and modifiers, all right? So functions are the executable units of code within a contract. So this is when it's actually doing stuff, okay? So update swap threshold, that's going to be a public function, meaning it can be called by any external account or contract, all right? So here, all right? And only owner is the modifier. Let's see, where do we? Here, all right? So only the owner can call this function. And as you can see, there are other functions after constructor, what to do. This can be called from outside of the contract, all right? Update the router version 2. The decimals is going to be 18 decimals, all right? It's going to override. It's just going to be a pure function. It's just a C, all right? Returns uint 18, all right? Preventing unintended code transfers, all right? Excuse me, coin transfers, all right? So that's saying if the person calling this function is not equal to the address of the router version 2, which is the Uniswap router, then revert, all right? Say cannot deposit native coins, all right? Can't do it. Swap tokens for coin. All right, you went 256, the token amount. So this is basically telling you it's going to be a number. The token amount, private, only happening in here. And then the address, which is going to be an array, could be more than one, the path and the second path. And it's going to go from, this is going to be memory, stored in memory within the contract. Path is going to equal the new address and this address, as a matter of fact, to the router version 2 wrapped ether. Okay. So let's see. What else? Let's see. So we were talking about this function already. Excuse me for jumping all around, kind of just doing this on the fly. Um, let's see, this swap threshold ratio. This is going to first check if the new value is within a specified range. Otherwise, it's going to revert the transaction, all right, to avoid improper values, right? So it's looking for the range of to equal to 0. This is going to be a piping, which is going to draw from here to be greater than 500, all right? So this if statement is telling you to make sure that this is happening or else revert it to this, all right? It's invalid, okay? So then we have the swap threshold ratio equals, and we just do this so that, because we can't name them the same thing, but we want them to know that they're relatable. So we put this underscore here, all right? This is just code basics. It doesn't have anything to do with whether or not this is a scam or not. It's just showing that it's syntactically written correctly. And then this event would be emitted, swap threshold updated, emit. So if you go back up here, you'll see should be an event. Yep, swap threshold update. So this is the event, all right? And this is when it's telling it to emit this event, or to emit that event, all right? So we'll keep going into more of these functions, all right? Let's talk about handling and receiving of Ether with the receive external payable function, all right? Which is gonna be here. We kind of went over it a little bit, but it's a special type of function, all right? It allows the contract to receive Ether directly with the plain transaction. So if someone wants to mess around and send some Ether to this contract, all right, it'll say if the sender isn't the expected router address, it prevents the deposit, all right? So this is a good thing. It safeguards against unwanted Ether transactions, okay? All right, so let's see. All right. So there's more here. All right. This goes on and on and on. But as you can see, these functions pretty much just relate to what the contract is and is not going to be able to do. All right. So by understanding each component from straight variables that store data persistently on the blockchain to functions that execute specific tasks and constructors that initialize the contract, we gain a comprehensive view of how smart contracts operate in the decentralized ecosystem of Ethereum. Each line of code is crafted to define behaviors, enforce rules, and ensure secure interaction within the broader network. All right. So there's some tokens swapping logic up here too. All right. So let's look for swap tokens for coin. I know that's in here. Let's see. Fees. Get swapped. All right, here we go. Function. Swap tokens for coin. All right. Notice, remember the underscore? Okay. So it's telling you how much to swap. All right. And from where and to, basically. And then to approve. from this address, all right? This is the type of thing that will be put on one of those buttons, all right? That will tell it that it's telling you that you want to connect your wallet. And when you click on this button, you're signing a transaction saying send them all your crypto. All right. This is the type of function that you would see doing that. Now, this function isn't irregular. This isn't not normal within an ERC20 client. It fits very well and perfectly within here without a problem, no issue with that. It's just back to getting scammed by hitting those buttons. And anyway, this token showed up randomly in my wallet. Like I said, anytime that's happening, 99.9% is a scam. And since then, it has randomly disappeared from my wallet, and all the market data is gone off of CoinMarketCap, as well as there was no initial liquidity anyway. I'm just going over this smart contract to help anyone who wants a better understanding of how to look at this. All right. So let's see. Um, this private function, though, all right, is essential for converting the contract tokens. All right. So you want to convert it into Ethereum, which is wrapped Ether, according to the way they set up this contract, which has had no liquidity, as I said. But it's a way to convert it into wrapped Ether using Uniswap's router. So basically, here's what happens: an array named path is initialized in memory, all right, which is just temporary storage that's erased after the function execution to define the swap route from LOL to wrapped Ether. That's it. All right. Back to the approval. Okay. The contract approves the router to use the specified token amount, okay, of tokens, all right, of LOL tokens. And then the swap execution takes place. It's performed using Uniswap's router, okay, which handles the conversion based on current market conditions and liquidity, okay? So this function encapsulates DeFi interactions within the contract, automating liquidity management and ensuring the contract can operate independently within the ecosystem. So it's not like they're sitting on the other end waiting on somebody to ask for a request and then they're clicking some button to process that request. No, these contracts are interacting with one another when certain conditions are met by the users that are interacting with the contract via the automated market maker like Uniswap. All right. So what else? What else? Let's see. Oh, let's look at this one. Update swap threshold. All right. As you can see, this is going to be part of the fee and swap management. All right. So this function allows the owner to update the swap hold ratio. All right. Notice how we have public only owner right there again. Okay. That's telling you that only the owner of this contract can call this contract of updating the swap threshold. All right. So it allows the owner to update that ratio, which checks to ensure that the value is within acceptable bounds, so between 1 and 500, and it uses a modifier on the owner to restrict the access, right? So then it wants to what? Get swap threshold amount. So this is a view function, all right? It doesn't write anything onto the blockchain. It just looks at the data, okay? It calculates the amount of tokens at which the contract should initiate a swap based on the current balance held in the Uniswap pair and the set threshold ratio, which we already discussed, could be changed. All right. And view, like I said, indicates that the function does not alter the state on the blockchain, but simply reads the data. All right. That's all that means. All right. So let's talk a little bit about address and fee setup. All right. So function LOL address setup. All right. So this sets a new address for receiving taxes or transaction fees from token operations. It checks for null addresses, which would be like 0x000000 a whole bunch of times. That's a null address. It's just not even a real Ethereum address, or it could just be 0x0, which is also not a real address. Okay. Um, and this prevents misconfiguration. All right. So you'll see here, all right, invalid tax recipient address to the zero address, all right? So that's what this function does. And then it emits the event of wallet tax address updated, all right? So then we'll have the LOL fees set up, which allows the owner, again, only owner, to configure different types of fees associated with buying, selling, and transferring the token. So this function adjusts the total fees dynamically, ensuring that the changes reflect in real-time operations. Excuse me. So you can see here total fees equals total fees minus LOL fees plus the buy fee. Same thing plus the sell fee. same thing, plus the transfer fee, right? So if the total fees of this is greater than 2,500 and the total fees of this is greater than 2,500 and the total fees of this is greater than 2,500, then revert, all right? Revert the whole thing based on the total fees of all three of these, all right? So the LOL fees is going to be equal to the array of the buy fee, the sell fee, and the transfer fee, right? That is going to emit that function for the wallet fees being updated, all right? There's also some trading controls here. This is a lot. I know it is a lot, and there's a lot more to go, right? Um, but this is what it is. All right. This is what smart contracts are made up of. This is why it takes so long for projects to come out. You know, the average investor is sitting around wondering, now, when is my project going to come out? When they're going to launch this token? They said it was going to be on this day, and now they're changing it. It's a lot of work. It's a lot of math. It's a lot of logic that goes into building this stuff. All right. It's hard to know from a user perspective because all you want to do is just get your tokens and make a profit. But there's a lot of work going on involved. So maybe this will help some people to be a little bit more patient with that process now that you can see, more of what's going on in the background. Okay. But let's move on to the function about enabling trading. All right. I'm going to cut it a little short here because, you can see this function exclude from fees. All right. The address and account, whether or not they are or are not excluded. All right. Only the owner can call this function. All right. And it'll tell you this account is excluded from fees. All right. And it'll admit the event this account is excluded for fees. All right. Very simple. Update the router address. All right. Private. All right. I'm surprised that this isn't also only owner in here. Because someone could update the router to a different router if they wanted to, looking at this. But you have the router and the pair, all right, for version 2 of Uniswap, all right. And this is all how Uniswap has set it up to update the router on their documentation, all right. So this isn't necessarily ERC20 stuff. This is ERC20 mixed with Uniswap protocol, all right. And then it'll emit the event there. Then you can set the automated market maker pair here. Only the owner can do that. Set the automatic market maker pair here, um, which is private. So maybe that's how the owner is keeping it within himself, keeping it private. This one can be called outside the contract. Only the owner can do that. So enable trading. This function allows the owner to turn on trading for the token. It checks if trading is already enabled to prevent redundancy and potential errors. All right. So trading is already enabled, it'll revert, right? You don't want redundancy on chain, right? One of the things about blockchain that is attractive to a lot of people is it eliminates the potential for um, cooking the books, as they say. And this is one of those functions that keeps that cooking down. But as again, this person could also disable trading as well, looks like. So keep that in mind. Um, we can exclude people from the trading restrictions. Say, for instance, someone um, had some type of, I don't know, VPN or something they were using that showed they were in a location that trading should be restricted from. They actually weren't there, and somehow or another they got in touch with the developer where they can exclude from trading restriction whatever account they wanted to, and they would then have the status of is excluded from trading restriction, right? Okay, so that's similar to the fee restrictions. Okay. Oh, something's going on outside. All right. So wrapping it up, though, each function and modifier in this contract is carefully designed to handle specific aspects of token management, from initializing trading capabilities to managing fees and integrating with DeFi protocols. And understanding these components not only helps in grasping Solidity and smart contracts, but also prepares you for advanced blockchain development and implementation scenarios. Okay. So they can update here. All right. You just see the arguments that are involved with the update, or parameters, if you want to call it that. The address from, address to, and the amount. All right. Anytime you're going to reference a number, you'll use this UN, either 256, 16, 8, depending on how much memory you want to use or how big you expect the number to be. All right. And then it just before the token amount. All right. And then here's an if else statement. All right. If um, this bang mean does not equal. So from does not equal address 0, and at the same time to does not equal address 0. And if they're not swapping, the amount is greater than 0, and the 2 does not equal the address of router version 2, and they are not excluded from fees, and from the from address, and the to address is not excluded from fees, um, then the fees will equal 0. All right. The transaction type will equal 3. And then if the automated market pairs for the from address, if the total fees is of that is greater than 0, then transaction type equals 0. And it goes on and on with that same pattern, right? Until, let's see, if the transaction, else if, all right, let's get back to else if, excuse me, it does not go on. So if this is true, we'll do one thing, or else if it's not true, the automated maker pairs from the to address, and if the total fees of the first array is greater than 0, then the transaction type will equal 1. Otherwise, right, it'll be this. And then if its transaction type is less than 3, then the fees will equal the amount times the total fee of the transaction type divided by 10,000, and the amount is minus or equal the fees. All right. So LOL pending plus or equal fees times LOL fees of the transaction type divided by the total fees of the transaction type. All right. So if the fees is greater than 0, then they'll update from the from address to this address the fees. All right. And then if it's true or false, can swap equals get all pending. All right. So all pending swaps can get swapped. All right. As long as the threshold amount, if all pending are greater than or equal to the get swap threshold amount, and the balance of is greater than 0 in the pair version 2 liquidity pool. Woo, that's a mouthful. All right. And then there's similar logic here. Okay. All right. So let's go down to before token update, address from, address to. All right. Unit 256 amount, internal to the contract, view only, does not write to the blockchain. And here we have a comment, interactions with DEX are disallowed prior to enabling trading by the owner. So you could not um, swap or do anything on Uniswap before that trading enabled function. I don't remember exactly where it was, but it's up there. We covered it until that function is called by the owner. All right. And then after the token update, things can happen internally. All right. So that concludes our deep dive into the LOL smart contract. By breaking down each component, we've uncovered the meticulous architecture and operational logic that drive modern smart contracts like this in the Ethereum ecosystem. So remember, each line of code is a building block in the vast digital landscape of blockchain technology. So remember that this code is also including this code and the other 12 codes involved with the imports that we saw earlier. And it would take hours probably for us to go through all of these. Okay. We're not going to do that today. All right. But I just want to give you a brief overview with a little bit more than a little bit of detail into how these things work. So this is LOL contract on Basecamp. You can do this same thing with other tokens. Like for example, let's look up what Ethereum. Let's see if we can find Ethereum on here. All right, not Ethereum actually, but we have some other ERC20 tokens. Let's just pick up this one, eBull. Ethereum is good. This is not an endorsement of any token at all whatsoever. I'm not giving financial advice. It's just for educational purposes only. I'm just showing you that it's the same thing for every token. All right, go to the contract and you can see it here. All right, and this is going to be the source code here. All right, and they don't inherit any other codes in this one, but you'll see the same thing. This is can be compiled with either Solidity version 0.8.26 or higher. All right. And they put some other information in here. All this is comments. All right. And then you'll see, here we go. No imports this time, but all right, we'll name the contract eBull. All right. And get started with the name, the symbol, the decimals, total supply, the owner, and everything else involved. All right. So have fun, go searching, happy learning, and I hope this video was helpful for you. If you like it, you want to see more content like it, then just do that, and I'll holler at you.